I'm going to get a handy dandy highlighter just because this is a lot of reading, so I'm going to highlight the stuff. So a scale diagram is a drawing that is an enlargement of a small object or a reduction of a large object. Makes sense. Have you guys seen like packaging for, I don't know, products like cookies or something, and they show you like this giant cookie, but then it says like not the actual size of the cookie, and they show you like a big picture and you get a little tiny cookie. And the scale of the atlases and stuff like that. We have to use those so that we can make something that's easily used. And we talked about maps and atlases. We couldn't have a map of Canada the size of Canada. We use scales all the time. A scale drawing of a building or a bridge is the same shape. So it has to be the same shape of the actual building it represents, but it's just a smaller size. Okay, so same shape, and it has to be reduced by the same dimensions. Because if you reduce something by different dimensions, it will look wonky. It will look not good. A diagram that's an enlargement or a reduction of another diagram is called a scale diagram. I'm going to highlight that whole sentence there. Oh, you guys can't see that. I'm highlighting things that are not on the screen. All right, this is a big one, proportions. And really what we're doing is we're comparing two fractions. So these are ratios and they're super handy. What's going on with the phone, guys? What? Nothing? You're just stabbing it with pencils for fun? All right, okay. All right, so we're going to be looking at two fractions and we're going to be doing some algebra. We're going to be using some formulas too. Okay, so here's the scale factor formula. To calculate your scale factor, you're going to take the length of the scale object, so that's your drawing, and you're going to divide it by the length of the original object, so the actual thing. So usually, this is the equation rearranged. So scale factor is equal to drawing over actual, or if we want the drawing size, we take the scale factor and multiply it by the actual, or if we want the actual size, and we're going to do work with all of these, so don't worry about that. If we're looking for the actual size, we're going to take the drawing size and divide it by the scale factor. Some terms used drawing are, like when we talk about the drawing, it is the scale diagram. It's the thing that we've reduced or we've enlarged. It's the new shape. Actual, sometimes we use the word original. That will show up a lot. When we're talking about drawing, we're talking about the scale diagram. And a scale factor can be expressed either as a fraction or a decimal. Okay, so this is nice because sometimes we don't love fractions. But I would challenge you guys that if you're not a big fan of fractions, that you practice using them, especially us heading on to intro. We do use fractions a lot and they can be really helpful. Okay, so Mr. Salmon floating around right here. The picture of a salmon is to be enlarged for the cover of Fishing Weekly. The actual length of the photo is 8 millimeters. For the cover, the photo needs to be enlarged to 30 millimeters. Determine the scale factor for the picture. All right, so scale factor is equal to the drawing over the actual. All right, so this one, so the actual length of the photo is 8 millimeters. So that is going to go into, oh, my pen. They're brand new. Not my favorite pens. I thought they'd be much better than they are. Okay, the 8 millimeters. It's the actual. It's the original picture. It's the original picture. So the 8 millimeters is going in. And we know that the photo needs to be enlarged too. So the new picture goes in for the drawing. Okay, so we're just going to fill that in. We don't have to worry about units of measure with scale factor. So we're going to have 30 millimeters divided by 8 millimeters. So so we don't have to worry about units, but they're millimeters divided by millimeters. So those go away. We don't have to worry about those if they're the same. If they're not the same, then we have to convert it. And I don't know if you guys have done a lot of work with the converting, but we'll work on it here. Okay, do you like fractions or do you like decimals? You guys are like decimals. Okay, I'm going to do it both ways. If I were a fraction, I want to reduce this. What can I take out of both of them? What number can be divided out of 30 and out of 8? 2. So if I divided that by 2 and divided that by 2, I'd get 15 over 4. For the rest of us mere mortals. So if you wanted to use a fraction, we do the reduced. So if you're using a fraction, you always want to do the reduced. 15 divided by 4 is 3.75. So we need to times all the dimensions of the original by 3.75 to get it enlarged to what they need for the cover. So it's pretty straightforward figuring out scale factor, but sometimes we throw tricky ones in there where they're different units of measure, like meters to kilometers, things like that. All right, everybody get that? Makes sense? Clear as mud? All right, now we have a bug. Looks like some sort of beetle. Okay, we plan to enlarge the photo by a scale factor of 9/2. Calculate the dimensions of the enlarged photo. All right, so we are looking for the drawing. We're looking for the new one, and we have the information about the original. So this is the actual, and this is the drawing. Oops, sorry, you guys can't see my words. Why are you guys hitting each other? You guys are playing with the cell phone, you two are hitting each other. It's a tough day to be part of our class. All right, I'm gonna go back to this front page. We wanna know what the dimensions are of the new photo. So how do we find that? If we want to know what the drawing is, we're going to take the scale factor and multiply it by the actual or the original. Okay? So we're going to we want to know what the drawing is. We're going to take the scale factor and we're multiplying it by the actual. And those are just that formula rearranged. Easy peasy, already done for you. So we have to do it twice because there's 2 dimensions. We have a 6 and we have a 4. So we're going to do the 6 first just because. So what's the scale factor? 9/2. The actual dimension is 6. And that would be centimeters. So in this unit, we're going to be making sure we put the units in there when we are talking about the dimensions. And then we're going to do this again. Okay, you guys are going to do this. I'm going to pause, and you guys are going to do the second one. So drawing equals scale factor, which is 9/2 times by 4. Okay, you guys go ahead and do that math. Did everybody get 18? Hopefully. You did the 4.5 times 4 and got 18. And so our new dimensions will be the 27 centimeters by 18 centimeters. That's like a ruler size long picture. Okay, here we go. Now we're going to draw stuff on graph paper. All right, if you have a highlighter or a pencil or something, you might want to just maybe color in the shape. It's kind of hard to see. It's kind of hard to see there. Good morning. All right, so we want to draw an enlargement of the shape using graph paper by a scale factor of 3. So that means each side, if this was 3, this is 2, this is 1, that's 2, and that's 4. We're going to take each dimension and times it by 3 to get the new, bigger picture. So what's 3 times 3? Anybody? Hopefully, 9. Yes? So we know that the new height isn't 3 anymore. It's going to be 3 times that, so it's going to be 9. So my first line, I'm going to use a ruler because I don't draw straight, is I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my new height. That's a new height of 9. And so this was 2. I'll give you a sec to draw that straight line at 9. So we did this one. That one's done. All right, now we're going across the top there. What's 2 times 3? 6. So now we got to go 6 across the top. So 1, 2, 3, 4, 5, 6. So that's my new dimension of 6. This was 1. So we did that one. This was 1 right here. What's 1 times 3? Hopefully it's 3. So we're going to go down 1, 2, 3. That dimension is 3. So that one's done. 2, you guys told me was 6. So now we're going across 1, 2, 3, 4, 5, 6. So that one's 6. And that one's done. 2 again, so now I got to go down 6. 1, 2, 3, 4, 5, 6. And 4 times 3 is 12. So this should be, if we've done all of our math right, this should be 12 right across the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And look at that. We took this diagram and we enlarged it by a factor of 3. So this side, this shape is 3 times as big as that one. And that, ladies and gentlemen, is the beginning of scale factor. It's going to get a little bit more complicated, but for today, that's all we need to do. So you guys have 4 questions to complete, and you have the majority of the period. So I'm going to ask that you really work hard to get this assignment done before you leave. And if you have extra time, I'm waiting on a bunch of inequality assignments.